Hey, go ahead, if you will, and open up a new project in IntelliJ. We're going to make sure we cover some important processes here in this. It seems like some of you are still struggling or having some difficulties with the JD case being set up correctly in IntelliJ. So we're going to walk through that here at the beginning. Elijah, you'll need to pay attention to this because I think you're missing this as well. Okay? And then we're going to get into talking about methods. And really the only way you can understand a method is to see how it works and the different ways that you can use it. And then we're going to talk a little bit about the assignments this week and using Cengage. And then as we get close to about 4:30, I need someone to remind me because at 4:45 we need to start wrapping things up. Okay? All right. First of all, when you're going to start your new project, it doesn't matter what you call it. Just make sure you call it something that's memorable to you. So for today, because we're looking at methods, we'll just do method examples. Okay? And then you have your location. I have a GitLab folder. I'm going to change this because I don't want it in that folder. Let's see. There's my GitHub folder. I'm going to put it there. We have create Git repository. So if you actually want to store your code and keep it on GitHub for remembering it, you can do that here. It is going to ask you for your credentials. So I don't want you to get too tied up with that. If you want to investigate that after class on your own, automatically connecting your GitHub repositories through one click in IntelliJ, you can certainly do that, okay? Big thing here you'll notice is there's Java, there's Kotlin, there's Groovy, there's HTML, and there's a plus for other things like Python and Scala and so forth. And then you can also install other programming language environments. The nice thing about IntelliJ is you can, as a student, you can use for free the IntelliJ Ultimate, and that gives you access to all of their whiz-bang nice plugins and such for programming. Okay? For this class, all we need is the Community Edition, but if you really want to dig into it and learn how to use it, I recommend it. For those of you who are interested in software development, IntelliJ is one of the premier integrated development environments used just about by every Java programming shop that's out there. Okay, and so it's a good idea to learn it. Some shops still use Eclipse, and Eclipse is very painful to use, but that's neither here or there. Anyways. Then we have the build system. Let's step back first. We have language. Java, Kotlin, and Groovy, they're all JRE-based languages. Okay, what does JRE mean? JRE stands for what? Java Runtime. So you have JRE, you have JVM, right? Java Virtual Machine, Java Runtime Environment. They're kind of synonyms for the same thing, but Groovy is a shortened version of Java. So you don't have to type out all of the extra phrases. For example, in Groovy, you can just say out, or you can just say printline instead of system.out.println, things like that. Kotlin is a language that was developed by JetBrains for IntelliJ. And it runs on the JRE. That's what they are. All right, then you have your build systems. For this class, we're only going to be using the IntelliJ build system just because it encapsulates everything. But if you're interested in learning more, Maven and Gradle are two very good build systems that are used by professional build environments. And there's going to be reasons, there are several reasons why to use them for the big Java projects. We may get into using one of these a little bit later as we progress in the class. But for right now, we're going to do everything through IntelliJ. All right, you get down here to the JDK. If you do not have a JDK listed right here, okay, this is very important. Elijah, do me a favor. Do you see this right here? Do you have a JDK listed here on yours?
Yeah.
Okay. If you don't, you can click on this and you can download a JDK. Okay. I've got 20 and 21. I'm going to switch this up to 21. Okay. Very easy. Then you have advanced settings. You have the mod. You can create module names and so forth. We're not really going to mess with that. Okay. We're going to go ahead and click Create, and let me drag this back over to the other window. Okay. We have, at this point, you should have a folder called .idea, and this folder here contains all of the build specs for building a project in IntelliJ. You really don't want to mess with this. The .idea folder is, as you notice, starts with a dot, and this is based on the idea that folders that have a dot in front of it are considered invisible. Okay, so the only way you can see them is using in Windows, you have to turn on the visibility setting to show hidden folders. In Linux environments, when you type ls, it only shows you those that are listed that should be visible. If you type ls space -la, it'll show even the hidden files, which is those that begin with a dot. Then you have the out, and this is where it's going to compile the code to, and then we have our source directory. And for whatever reason, I have a happy birthday class, and I don't know why I did that. So I'm going to go ahead and remove, it's not my birthday, so I really don't know what that is. I think this is leftover plugins from another code source I was messing with. If you have sample code in there, just delete it, okay, for our purposes. Now I'm going to go ahead and right-click on the source directory. Make sure you do it on the source directory. And click Java class. Let's talk about some of the classes we have here. We have class, we have interface, we have record, we have enum, and we have annotation. Okay. We may get into records later on. We'll definitely get into interfaces, and I know we'll touch enums, but I don't think we're going to talk too much about annotations as far as you creating them. Now, you will use annotations in this class, but most of your stuff is going to be classes. We're going to go ahead and just call this method examples. Just to keep it simple, we're going to call it the same as our project. Okay. Once you have that, hit enter. And you should see what I have here on the screen. Why is that not letting me? Can't. There we go.
Wait, is it Oracle, OpenJDK, or Amazon Corretto? Amazon Corretto, right?
Amazon Corretto. Okay. Now, at this point, we have a basic class, right? There's nothing in it. And with this class...
Sir, it doesn't contain the out.
Chorito Cristoria.
Sorry about it.
It's alright. The out class only exists after you compile the file. How do I do that? You have to compile the file.
Tell you what, Elijah, why don't we get through this part and we'll compile something and then you can see it, okay?
Okay.
All right. All right. This class by itself is non-executable. So what do we need to make it executable? Yeah, we need a public static void main method. And with IntelliJ, it gives you these shortcuts. It's kind of like in VS Code, the, what was it called? The emit. It's kind of like that. Just type psvm and hit tab, and that will automatically create your entry point for your application. Now, public static void main is a method. It is a special kind of method, and you should not have two of the same methods. Okay? So the method signature of a method you create should not already exist in that method. Okay? So for example, I should not create another one of these. And you can see that IntelliJ is warning me, and it says what? It's already defined. Now, a good way to learn this as well is open up your terminal at the bottom and let the Java runtime inform you of the type of error that's going to occur. So we're going to go into the source directory. Okay? We're going to do an ls. And I'm going to make sure I save this first, but then I'm going to type JAVAC, JAVAC, and the name of my class, method examples. This is going to get into the types of errors that you're going to see. You have compile time errors, and you have runtime errors. With a compile time error, it's going to tell you, hey, you can't do this. And the log itself is going to reflect what the issue is. So it says, at line 6, there's an error. The method, main string with this method signature of array, by the way, this string with the brackets is array syntax, okay? It's telling you that it's already defined in the method examples. So everything up to here is fine, we can see, because the caret underneath is telling us where the error begins. So line 6, we'll look at line 6 right here. This is where the error is at. It's a good idea to take time looking at what the compile time error messages will say versus the runtime error messages. So runtime messages would occur through what command? If compile time occurs through javac and you're compiling the class, what does a runtime error occur with? While the program is running. But it'll occur when we type Java, the name of our class, right? If there is a runtime error that occur, you will catch it there, and then you'll have to address it in your code again. Okay? All right. So this is, the first rule is the method cannot be already created. It cannot have the same method signature. So let's talk about the method signature. First of all, we have the access modifier. All right, everyone say access modifier.
Access
modifier.
Right. Access means what level of security is designated for that entry point. So the access modifier for this one is what? It's public, right? Now, other methods can have other access modifiers. You could have, of course, private. You could have protected. And you could have what's called default, where it's not specified. Public means that this class and the methods in that class that have the access modifier of public are accessible by anyone outside the class. All you have to do is instantiate the class. We'll talk about what instantiation means a little in here in a little bit, and you can actually access that method. Okay? So public, private, protected, and default. Default would be doing this. That is a default access modifier. Okay? All right. The next thing that we see on this method is the second keyword, static. And what this means is that you do not have to instantiate the class in order to access the method. Okay? Means that all you have to do is just say method examples dot, and to give you an example, we could do that. Let's create another method real quick. We'll call this public static void hello, and I could type method examples dot main. I don't have to instantiate it. I could just call it directly like that. I do have to provide, though, of course, what? The arguments for that. I have to provide the parameters. Okay. Well, let's keep this as is for a moment. So we have static. The big thing I want you to remember, and just kind of say it to yourself, I don't have to instantiate if I am static. Okay? And this kind of comes, the idea of something being instantiated or being static is going to really deal with the idea of variables and how we store things in memory. But we're going to get into that a little bit more in a second. Then we have the return type. So what does this method return?
Nothing, cannot return.
It returns nothing. But in Java, it's very strongly typed, and so everything has to be specified. And that's an important thing for a programming language because it protects you from making mistakes. Okay? So in Java, everything has to have a return type on its method. You don't have to have an access modifier. You don't have to have it be static, but it does have to have a return type. That is requirement number 1. Okay? Requirement number 2 is the method name itself. You can have methods like this, but that's bad programming practice. Okay? Correct programming practice is to keep all of your method names lowercase. Unless your method name is 2 or more words concatenated together. Let me give an example. We'll say void hello, my name is. In this example, the method name itself is actually several words put together, but we're using something called camel case. Okay? You kind of get the idea why they use camel case. Camel case is like the back of the camel, kind of goes up and down like that, right? In camel case, method names always begin with a lowercase for the first word, and then each word that's appended is uppercase to give a sense of a readability is what really it's about. You can create your names like this. Hello, my name is, but that tends to get hard on the eyes and hard for reading. Okay, so the best practices is always to create it in camel case. Okay? Class names, on the other hand, should always begin with a capitalize, okay, capital letter. And the class name itself must match the name of the file exactly. If your file name is method examples _1, then this over here must have method examples _1. Let me give an example. If I change this, IntelliJ is going to tell me, hey, this doesn't work. In fact, if we save it and we try to compile that, it's also going to give us the same error. Method example is public, should be declared in a file name method example.java. So the class name should match the file name. Everyone understand? Okay, now your method itself, basically your method is taking a block of code which only runs, bless you, which only runs when it's called. Everything that I have over, where'd my mouse go? There it is. Everything I have in here is called the entry point. Inside my main method is the entry point. So I could string together several things, right? System out print line, hi, int 5 plus 5, or excuse me, int num equals 5 plus 5, system out print line, num. I could do all of those things, and it's just one sequence after another. It starts here at this line, it goes to the next line, it goes to the next line. It's a set of instructions. And what do we call in programming a set of instructions?
Algorithm.
Very good, algorithm. A method is basically taking that algorithm and making it reusable. Could you imagine if I had to type this, like, if I had to use this logic 20 times without having a construct like a method? It would be frustrating, right? Because there's so much repetition then in what I have to type. Methods give you the ability of ability to reuse your logic. And so if you have logic that can be reused, well, that makes you think smarter, not harder, right? You work smarter, not harder. You accomplish things in a fashion that you can get stuff done. All right, so far we talked about the public access modifier, the fact you can make it static, the return type, and then the method name itself. And the last part, of course, is the method constructor. This is the method parenthesis that contains whether it's going to be something that's just called or something that you pass data into. So down here in hello, we got hello, my name is string. Let's do this. We'll type system out print line greetings plus name plus that. Now, what I've done is I've created a method that passes in a name and then outputs a message. So let's come up here to our code block. I'm going to delete this random bit of junk I put in. And let's attempt to use that method name. Well, this is interesting. Can anyone tell me what the problem is? Why IntelliJ says it's not accessible? I mean, I know the reason why, okay? I'm just priming the pump. You all know the reason why IntelliJ is complaining. Let's run the code and see what the compiler says. Line 3, okay, there's line 3. Non-static method, hello, my name is, cannot be referenced from a static context. So what's the static context? The context is its caller. This is the static context. So this gets to the common dilemma that we always face when trying to access our methods. There's two ways we can access this method. The first one is simple, just doing that. Now it's done. Compile it, and it's complete. In fact, I could run it now. Right? Greetings, Michael. Because I've passed information into the hello, my name is, and I'm outputting it there. But what's another way we could deal with this without making it static? This gets to the idea of how variables are created in memory. Now, everybody's computer, down to the smallest calculator, has RAM in it, some type of storage capacity. And that storage capacity is based on specified instructions of how a selection, a physical piece of that is going to be used. We talked about some of that last week with the idea of, with our data types of int, short, long, double, float, string, byte, Boolean, right? Those are all, in fact, those ones that I listed, do you all know what those types of data types are called? Primitive, absolutely. Yeah, they're primitive data types because Java is considered an object-oriented language, but it's not truly object-oriented because primitives you can just use without having to do special declaration. Okay? So this is what I mean. And this relates to why we can't call hello, my name is. In memory, when I specify and I say int equals some number, I'm actually taking up physical space in memory to store that variable. Okay? When I declare it as final, I'm telling the compiler for the life of this program that area of memory cannot be changed. When the program dies, the Java runtime says to the operating system, okay, it's okay now to release that memory. Okay? Now you could think of problems that come with certain operating systems, Windows, that don't release memory properly. Over time, the system gets slower and slower and slower until you finally have to reboot the machine because it's not releasing the memory properly. Have you all ever noticed that? A lot of your Linux, Unix-based Mac OSs, they actually release memory in regular patterns so that you don't run into that problem and you don't have to reboot your computer. All right? The variables here have to be released, but they also have to be specified. So in this instance, I have to define this variable to be stored in memory. And the way I'm going to do that is I'm going to say method examples. This is the class, the data type. I'm going to give it a variable name, and I'm just going to call it me because it's method examples. Okay, equals new method examples. Now, what I've done right there is I've told the Java runtime machine that when it executes, it's going to, for the life of this context right here, as long as this method is considered active, it's going to have this piece of data stored in memory. And what defines this piece of data? Well, right now, what's defined in it is this method name here and this method here. So now we get to the question of how do we use hello, my name is. Because I've declared it, I can use it. Okay? So I've instantiated a piece of memory, and now I've made it available. Hello, my name is, and I've set it up. All right, any questions so far? Something that doesn't make sense to you? Yes?
We can make a comment on that row, the public static and void, right? Between.
You can put comments in between it?
Yeah.
No, I can't do comments between.
Oh, okay.
So if I put a comment in here, you see what happens? Yeah.
I mean, like the other.
This type of comment?
Yeah, like that. That's good.
Yeah, you can do that, but I'll give you a bad grade if you do that, okay?
Okay.
You can do that, but that's not best practice. Always put your comments outside your method, okay? For example, you could do these type of comments. Okay? Or you could put a comment here. Right? Instantiating method examples. Good question. Any other questions? Any other questions? All right, these are methods. Okay, these are the way we set them up.
Are
Yeah.
methods like almost the same thing as like functions in other languages?
Yes, they're the same.
Okay.
It's just in Java, they chose to call it method.
Just its own lingo.
Yeah, yeah, it is a function. Yeah. There are some differences in other languages. For example, in C++, if you were to, I think, do that, that's called a pointer, and you can technically add, you can send data through the method signature and back out the method signature with a pointer. Okay? You can't do that in Java. Java has defined your ability to set up data as to either come through the return type or to be passed through the method signature itself. Okay? All right, so let's do another example. This one we're going to do public. We'll have a return type of int, and we're going to do, let's see, is it cube? What is it when you multiply something by itself?
Square.
Square. I'm sorry, there we go. And we'll pass in another int, and we'll say num. The way we return the data in a method is with the return statement. And here we would basically then do num times num, right? So we could test that up here. We could say me dot square, and we're going to pass in, let's do 120. Now, here I'm not doing anything with it other than returning the value. Okay? So this gets to the next question of how we handle methods, how we deal with the data itself. We have something called left assignment. So someone walk me through how I would assign the value now of this method. Someone walk me through how to do it. Anyone courageous? All right, we know that square is of what type? It's returning an int, right? So we need then to say we're going to specify our data type, our variable to receive that value. Make sense? Okay. Now, of course, we could add a system out print line and say num, or what is this? Let's do this. Int num equals 120. Pass in num, and then down here I'll just say num squared is okay. Let's talk about what happened here. Someone tell me why I declared this as a separate variable. Okay?
If there's no declaration, there's going to be a reference error.
Yeah. Yeah. So I could, by the way, just say 120
I'm in school. Okay.
and 120, right? I could do that. But here's the problem. Anytime I have a number that's going to be used more than once, it needs to be assigned to a variable, right? So this, you always want to make sure you do it like this. If you know you're going to reference it, always assign it to a variable and then just use the reference. Otherwise, when you go back to change your code and you say, well, now I'm going to do 36 squared. Well, now I got to change it in two places instead of changing just the one location.
Yes.
Okay. If you have a phone call you need to take, please take it outside the class, all right?
Don't worry.
Okay, any questions so far? Any questions? All right, so when we run this, we'll do it again. We'll type javac method examples.java, because we have to compile it again because we changed our code. Go ahead and run it again. And we can see that the square root of 120 is 14,400. All right. Any other questions so far about methods? Any other questions? All right. So we have our methods here that we've defined. Now, we could also take this a different direction. There's other things that we could do with our methods, which are called overloading. Okay, does anyone know what overloading is? I already said that we can't have a method with the same method signature, but you can if you overload it. Okay, so let's do. Let's take and delete this right here. Well, actually, let's leave it the same. Let's leave it the same. We're going to create a new method. We're going to call it public static string print name. We're going to give it a parameter of string full name. Okay. Then I'm going to type system out print line full name. Actually, let's do this. Let's change the return type to void. There we go. All right, so I have public static void print name. I have a parameter called string and full name. So with method overloading, we could do a couple of different things here. First of all, it gives us the ability to for reuse, but just by changing the signature just a little bit. So we're going to say public static void print name, and then we're going to go string first, string last. Then we're going to, inside of it, call print name first plus last. So in this instance, we already have the method that exists, but by overloading it, now we also can have a a variation that gives us more expressibility, right? We could take it out a step further, and we could say public static void print name string first string middle string last. Then inside of here we could say print name, right? And we could basically just say first y'all understand why I'm doing that, right? To get spaces in between. Okay? And actually up here on this other method we need to do the same. So I have one method that does an activity of printing, and then I have these different methods that give us more expressibility in how we define the name. Then we could take it out a step further, right? We could say public static void print name string first string middle string last string suffix. You guys get the idea? So we're overloading this method and giving it more functionality. Now what happens is, I'm going to take out this last one just because I think you already get the idea. So what happens is now when I call, say, print name, IntelliJ gives me a lot of options. It says, well, which one do you want? Do you want first name, last name? Do you want just the full name? Do you want first name, middle name, last name? Right? And depending on whatever I choose, I can pass in those parameters. I could type Michael D. Rogers. If we run it, so slow. There it is. It prints out the name. Okay? All right. Any questions so far?
Right.
Yes.
You can also like put a numbers on a name, right?
You could. You could put. Yeah. You could put age in there, or date of birth, or any of that. Yeah. Yeah. Yes, sir.
For the print name method, for the amount of like strings you put inside the parentheses, would it automatically like know which one to run or which method to use?
It does. You brought up a good point. It knows based on the method signature. So this method signature here matches by the comma declaration, right? It matches the method signature here, right? In fact, I could have a different print name. We could have one like this. We could say public, come on, Mike, static, void, print name, and I could say age and string full name, right? And again, down here, I could just do this. I could say print name and basically go full name plus age. There we go, age. Right? It's all up to you. All right. This is one example using where the return type is void. But let's talk about another example. Down here we have int. How about we have squaring something different? What if we want to say public double square double num? Right? Well, we've actually now given ourselves flexibility for printing it that way. We could also do it like this. We could say public float square float num. Again, same idea. Return num times num. All of these are overloaded. We're overloading the method, but giving it a little variation in data type. Okay? All right. Let's switch real quick here. This is the basics for methods, but let's switch real quick here and talk about this week's assignment. Because some of you are probably going to flip out when you see project, the first project that is due. All right? I know some of you are like, project? I don't even get this yet. All right. So in week 3, we're looking at, we're covering methods. Basically what I've talked about today in the lecture is what you're going to find, but with greater fidelity and detail in the reading. Please make sure you do the readings. There's also a quiz over chapter 3 again for this week. It jumped out on me. There we go. There's a quiz this week over chapter 3. And course project, it's due the middle of next week. That's wrong. That's wrong because the course project is due the 14th on Valentine's Day. How cruel, Mr. Rogers. Who hurt me? I'm gonna tell you, this is not a hard program. Okay. In fact, are you ready for this? You got your IntelliJ ready? Some of you are like, I don't know. What are we? I'm trying to prime the pump here, guys. You're ready. Okay. Let's go to File, New Project. And we have to call this, what is it? NMC Cagman Book Fund. All right, listen, my 2 kids went to Cagman, so I'm a little partial to it, so I'm sorry. AYU, all right? Yeah. Sorry, I know those of you who were what was it? The dolphin? Yeah.
I didn't know that's how it's done. That's how you know he's from
That's I heard y'all do your chant before the
Is that the famous Indiana dolphin?
I don't know. I'm not from Indiana. Yeah. All right. I've already done this assignment a couple of years straight, so this is very easy. You're going to go make sure you create. No, I'm creating mine here with a 1 after it because I already have the source code because I've done this so many times. All right. So again, make sure you make the class matches CAG Man Book Fund, right? All right. Here's your class. You're going to need a public static void main method. Do me a favor. Up here on line 1, you're going to need to put your author, date, and class identifier. Okay? Make sure you put that at the top. Let me pull back up. Where did it go? Here it is. So I'm going to read some of this to you. I went into great detail about describing this. To encourage good grades, Cagman High School has decided to award each student a bookstore credit at NMC. This is not true, by the way. Okay. That is 10 times the student's grade point average for the semester, for each semester each year. In other words, if a student has a 2.0 grade point average, they receive a $20 book credit. It's not a lot of money. Okay? For each semester, for each year. So you have to do the math. It's 4 years, there's 2 semesters per year, right? Over 4 years of high school, this will calculate out to potentially 160. This is designed to encourage students from Cagman to attend NMC and prepare for college. Here's your objectives for the coding assignment. Okay, let me bring it back over here again. Here's your objectives. Stop. Really? Has it got this weird stuck area now? Wow, it's stuck in this strange area and I can't move it.
Maybe if you use the flex pop method.
Wow, this is strange.
Try using the
Trying to do?
Try turning it off and on again.
Wow, that's all right. I guess I got to close it and come back to it.
keyboard.
Can you try dragging it and
Try hitting the very top with your cursor. Up, go up.
Maybe padding method 50 pixels on each side.
Yeah, this thing is stuck. All right, that is super strange. Let's see if I can drag it out further and.
Task manager.
All right, here we go. Your assignment is to create a class. Okay. You're going to need to capture the name of the student. So if we look at the code, name of the student, how we're going to do that? We'll say string student name. What else? A grade point average. When you run the program, it's going to prompt the student for this information. So we're going to need a grade point average. That's probably going to be a double. We need a year. So int year. And we also need a semester. So let's just do int semester. What else do we need to do? All right, that's the information we need to capture. So down here, let's make these public. Okay, so that means down here we need to have a scanner, and we'll call this input equals new scanner, and a scanner will accept any type of input string. Okay, so system.in is a type of input stream. Now, we need to say input dot next line. And this is going to be the student name, right? Hang on here. Grab your variables and put it inside the.
I was wondering. Yeah.
I'll just because I'm not gonna. There we go. Let's see, where is that?
How about for the scanner? Do we need the import for that? Or?
Yep, you do. It's up at the top already.
Oh, okay.
Okay. So system out print line. Please enter your name. My recommendation to make it easy for you guys, take out the ln so it's all in the same line. Okay. All right, let's copy this. Paste it a couple of times. Please enter your GPA. We're going to change this next to a next double. Means that you got to use the right one, GPA. Please enter your year. Use next int. Means we got to use year. System out print line. Please enter your semester. We're going to type in semester equals input next int, right? That's getting you started, right? That gets you started on the process of entering the data. Okay? So look at what it says next. You have to capture this for every year. So please enter your GPA for year whatever for the first year. Right? You have to identify it so that for the reader, when they're running the program, it's actually going to require the input. So here we have enter your first name. Michael, please enter your GPA for year 1, 3.6. Enter your year, 1991. Enter your semester, 1, right? So I've entered the data, and now it's captured here. But if you look at the requirements, after you capture the data, you're going to have to output it in this format. Okay? There is a little known command. It's system out print F format. And this is something that you're going to have to research on your own, how to print things with appropriate spacing. Okay? So you're going to capture all the data for all 4 years. Then you're going to do the calculation to get the average GPA per year, because you're capturing for semester 1, semester 2. It means you got to average the GPA. And then you need for that year to multiply for semester 1 and semester 2 what the credit is. Multiply for semester 3, semester 2, 1 and 2 for year 2, 1 and 2 for year 3, 1 and 2 for year 4, and then add it all up to get your final bookstore credit. Okay? That's your project 1. All right? Okay. What time is it? I've got a few more minutes left. And I unfortunately have to go open a new window because this thing went crazy on me. Unless it will let me. Yeah, I think it'll still let me. Let's see, we're at week 3. Let's see. All right. When we get to programming assignment number 3, it's going to require you to open in Cengage the programming environment. Okay. And unfortunately, if you do not have a GitHub account, you have to get a GitHub account. Okay. Does anyone in here not have a GitHub account?
Oh, I have.
Do you not have a GitHub account? Anyone? Okay. I can't see it, so I'm going to have to open up a new window. This is aggravating. All right, give me a moment. I have to do this quickly because Mr. Maui is going to be coming in shortly. Yes. Yeah, it's 4:40 right now, so.
Mike, please see the code.
I'm not sure I understand.
Okay. I am recording everything, so you can get the recording after class, okay? All right. I want to get this handled real quick so everyone can understand how this works. When you start your assignment, you need to make sure you don't have any ad blockers running. If you do, it's going to cause some issues. What this is going to do is it's going to open up a virtual VS Code environment that's connected directly to GitHub. On the right-hand side, it will have something called a companion tab. That companion tab lists exactly the code that you need to complete, and they are tasks. So this is kind of cool. Cengage is using the GitHub workspaces to, they're called unit tests, to validate your code. Okay? So this is going to load for a second, and it's going to load the connection. And it's very, very slow. But whatever you do, don't close that companion slide. Okay? Because you have to let it load.
So how's your day, Mr. Rogers?
It's been a long day. Been a long day.
It's been a long one, but it's so slow.
It's probably, I bet you Cengage does not have a server farm here in Asia. So it's we're communicating all the way around the other side of the world to a GitHub repository there. And all right, I just saw the ports come alive. Here we go. Here we go. Everyone put your hands up. No, I'm thinking more in line of you're about to get on the roller coaster ride and everyone goes, whee! Oh, the anticipation's killing me. Is anyone else's already loaded, or is yours still loading?
It's getting there.
We have one winner.
Oh yeah, time to buy a lottery ticket.
You're special, man. I don't know what you did to.
He's on his day.
Is yours loading the companion side?
Yeah.
Okay.
Two nights ago. Oh no, actually last night.
All right. So there's a companion slide and it has tasks on it, okay? And you have to follow each task. And when you finish the task, click the grayed triangle and it'll run a test. And it takes like maybe 30, 40 seconds for it to run the test, sometimes 2 or 3 minutes, okay?
There we go.
Yeah.
Wait.
It's still loading.
Companion. We need to wait for that.
Almost there.
Yeah, there it goes.
Extension's not even loading.
Yeah.
No, no.
We'll ask Mr. Maui to watch over it.
Even running
Like
it
over
takes
while
a
still
while.
loading.
It's still loading.
Come on, you
Guys,
can do it,
$147.
everybody.
Definitely.
This is $130 worth of Cengage at work.
Wait, you bought online?
140 if you want at the bookstore.
Dude, I bought it for 147.
This is more.
All right, I'm going to tell you task number 1 is to write the class name. So guess what that is?
Numbers.
Public class
Number 7.
numbers demo. That's task 1. If you do that and you click the gray triangle, it will run and go. Okay. Last week there was a task for, I think it was assignment 2. It was supposed to be inches and feet, and I was going to use the Cengage version, and it had a strange task called use the miles conversion class. It's broke, is what it came down to, which is why I had you all type the code out manually in IntelliJ and turn it in. All right, I don't know why this is taking so long. I think
Just the process.
Everyone get off the.
There we go. It's already.
it is.
You got a hotspot on it? Maybe that
Ron,
one's
you got a
faster.
question?
Yeah.
So, for that miles conversion assignment, was that graded or no?
I took it back out, so if you did it, it's already been removed.
What?
Do we get extra credit?
Yeah. Unfortunately, no. I apologize.
What's happening?
Wow, this thing is. It's still loading, so that's why.
Again,
What happened to us Mr. last week?
$140.
All right.
It was so slow.
Akira, right?
Yes.
So if you want to see the joy of what this is all supposed to look like, Akira already has it loaded on his.
Yeah,
And-
around Kira.
Yeah. Bill is coming to look.
I'm taking the initiative.
All right, so he's running the task, numbers demo, and yeah. And then task 2 is display twice the number. All right, for task 2, I'm going to give you a hint. These are public static void methods, okay? Public static void methods. You're not having to instantiate the class. If you instantiate the class, the task will fail, but this task will never tell you that. All right, there he got a,
You have to put the PSVM in order to run it correctly.
yeah, to run it you do.
Class.
Yeah. Okay, it is 4:45, and it is still loading. I tell you what, I'm going to close it and do it again.
Are
This-
all the assignments for the coding like that? For Unit 3?
Yes, for Unit 3, they're all through Cengage. Okay? It's so slow. I don't know what. Maybe it's the Wi-Fi here.
I think
It's not,
everybody's
it's
on
just
the same.
yeah.
All right, here we go. And now I have to give it.
Let's see.
You okay?
All right. Wow. I'm going to reach out to Teresa from Cengage and let them know because this is extremely slow.
Ask for a refund for the class too.
Yeah.
Oh.
There's no left or right.
You're so hungry?
Now, once you've done this, you can actually go out to the GitHub site itself as well. And you can see your code. You can download it and do it through Visual Studio Code. You should be able to execute it externally as well, and it will load it and run the test case. The important thing here is that after you hit each of the gray triangles and they become green, you have to click the bottom which says Run the Code, and after that completes, then you have to click the button that says Calculate Grade. Okay? Don't forget to click Calculate Grade, because it's all based on the test cases that are running in the background. Wow. Yes?
Is the task like really sensitive? Because when I was doing the work last time, I clicked the task like create public class and I was wrong, even though.
It's very sensitive, it is.
So do you have to do it one by one?
Yes. Yep. And I do not know why. Does yours show a companion in the left?
Which one?
Under here?
Black, right? You can like chat.
No,
Like
I think it's this one.
Yeah, there it is. It's under the Cengage.
So it's that Cengage icon.
All right, so here's the Cengage icon. It's supposed to display the companion under this. And if it's not displaying it, we'll have to work with Teresa. All right, guys, I'm going to bring it to a close today. If you still need help, I'm going to jump over to the other lab.